All right, welcome to the Step-by-Step Explainer Masterclass. We designed this specifically for you, postgraduate real estate decision makers. Today, we're taking a deep dive into the absolute critical core of property evaluation, facility lifecycle methods. Listen, if you want to make robust, truly defensible decisions in the built environment, you are in exactly the right place. Let's get into it.
Here is a quick look at our agenda. First, the real estate challenge. Second, life cycle costing. Third, life cycle assessment. Fourth, post-occupancy evaluation. And finally, putting it all together in the whole life toolkit.
Okay, Part 1, the real estate challenge. As property decision makers, evaluating a building based solely on its initial price tag is a massive mistake. It's a trap that catches way too many developers and investors. Because, let's be honest, short-term capital costs alone do not tell the full story. So we're going to look at the entire life of a building and introduce 3 methodological fixes to uncover exactly what goes wrong, financially, environmentally, and operationally, when we just ignore the long term. Moving on to Part 2, Life Cycle Costing, or LCC.
Transitioning from the drawing board, our first method is all about evaluating the total financial reality of an asset. Life cycle costing is essentially a technique for evaluating the total cost of ownership over an asset's entire useful life. We're talking capital, operation, maintenance, and end-of-life costs. The crucial point here is that LCC factors in literally everything from day one to the end of the study period using a specific discount rate formula, rather than just taking a quick glance at the initial sticker price.
Let's look at a practical example to make this concrete. Imagine you're procuring an HVAC system for a Grade A office building in Accra. System A, which is your conventional split system, costs 480,000 cedis up front. System B, a variable refrigerant flow system, demands a whopping 720,000 cedis up front. Now, at first glance, System A looks 240,000 cedis cheaper, right? Well, let's look a little deeper. When you do the step-by-step math over a 20-year study period at an 8% discount rate, it reveals a totally different reality. When we factor in not just the capital, but the annual energy costs, which, by the way, are substantially lower for System B, plus the maintenance, major overhauls, and the residual value, the true financial picture finally emerges. And when you crunch those present value numbers, you actually end up with a net present value savings of 47,059 cedis for System B. This brilliantly illustrates that despite the terrifyingly higher initial cost, System B represents significantly better whole life value for your client. Why? Because of its vastly superior energy efficiency over a 20-year lifespan. But wait, what happens if the discount rate drops to 5%? If we adjust our sensitivity analysis to a 5% discount rate, that savings absolutely explodes to 126,231 cedis. This just proves how incredibly sensitive your decisions will be to financial variables. At lower discount rates, future operating cost savings are discounted less, making those energy-efficient options vastly more attractive. You absolutely must always test multiple discount rates. Okay, Part 3, Life Cycle Assessment, or LCA. So we move from the financial ledger to environmental accountability. To truly quantify a building's cradle-to-grave environmental impact, you systematically follow 4 standardized ISO phases: defining your goal and scope, compiling your life cycle inventory, assessing the impact, and finally, interpretation. This structure ensures your environmental data is rigorous, defensible, and comparable. Let's apply this to the real world. Looking at external walls for a 100-unit residential estate, compressed earth block, or CEB, has roughly half the environmental impact of conventional sandcrete. It generates just 61 kilograms of CO2 equivalent compared to sandcrete's 123 kilograms, and it requires exactly half the primary energy demand. However, as analysts, you've got to weigh this massive carbon win against real-world trade-offs. For instance, CEB needs frequent re-rendering in humid climates, roughly every 10 years, and you absolutely must verify structural and moisture resistance. But on the flip side, it strongly supports EDGE and LEED green building material credits. It's all about balancing these factors holistically. Next up, Part 4, Post-Occupancy Evaluation. Now we move to the reality of human habitation. How does a building actually perform once it's occupied? Post-Occupancy Evaluation, or POE, generates the real-world evidence we need to fix current operational issues and improve future design briefs. We look across 3 distinct domains: technical performance, like energy use, functional performance, like space utilization, and behavioral and experiential performance, which covers occupant satisfaction and well-being.
Let's look at technical performance with an energy performance gap analysis. In a Kamasi mixed-use building scenario, the data reveals a really dangerous widening gap between the design target of 120 kilowatt-hours per square meter and the actual energy being consumed, which was 148.7 in year 1 and jumped to 160.5 in year 2.
Now, that performance gap isn't just a theoretical metric. It represents a staggering 89,910 SETI financial leak for the facilities management budget. Plus, it's an extra 21.4 tons of CO2 per year released into the atmosphere above the design target.
So, to understand the behavioral causes of this energy waste, we turn to the Occupant Satisfaction Survey, and this one boasts a highly reliable 80% response rate, representing 64 out of 80 staff surveyed. That gives us great confidence in the insights we're about to uncover. Out of a 7-point scale where 4.0 is neutral, 2 critical scores really stand out: acoustic privacy at 2.9 and summer thermal comfort at 3.1. These critically low scores directly explain the energy gap. Dissatisfied occupants are likely overriding central controls or plugging in personal fans to cope with the poor summer cooling and bad acoustics. And finally, Part 5, the Whole Life Toolkit. Let's see how all of this builds together by uniting these isolated academic concepts into a powerful, integrated toolkit for your careers. These 3 methods are not isolated tools. LCC handles the economics, LCA handles the environment, and POE handles actual use. The real magic happens right here in the feedback loop. POE findings feed actual data directly back into your LCC and LCA models, calibrating them for absolute accuracy on all your future projects. So, I leave you with this final challenge. How will you use these whole life metrics to stop guessing and start engineering the future of real estate? Don't just calculate these numbers to pass a test. Use them to build better, greener, and vastly more profitable realities. Thanks for joining this Explainer Masterclass, and keep questioning the true cost of the built environment.